So let's understand 3-bit down counter. So the sequence is 7654321 so since we are designing a 3-bit down counter using JK, so we're going to need 3 bits, so 3 flip-flops. So 2 bits means 2 flip-flops. So this is going to be our excitation table like what we have done earlier. Since for JK, you need to write the excitation table for JK and then write the present state as Q2, Q1, Q0, the next state as Q2 plus Q1 plus and Q0 plus. So J2, K2, J1, K1, these are all the flip-flop inputs. Like J2, K2 are the flip-flop inputs which has the output Q2, J1, K1, flip-flop inputs with output Q1, J0, K0, they are the flip-flop inputs with output Q0. So I'll write the state all the 8 states because it's a 3-bit, so maximum state is 7. I'll write it in a sequence so that it helps in finding the flip-flop inputs using K-map. So from 7, what is the next state? 6, 6 to 5, 5 to 4, 4 to 3, 3 to 2, and 2 to 1, 1 to 0, 0 to 7. Then find out flip-flop inputs J2 and K2. For this, you need to use Q2 and Q2 plus. So 0 to 1, it's 1x, 0 to 0 is 0x, 0 to 0 is 0x. So you have to write J2, K2. Similarly, write J1, K1, for which you compare Q1 and Q1 plus. So 0 to 1 is 1x, 0 to 0 is 0x, 1 to 0 is x1, 1 to 1 is x0. So like we write J1, K1 and map it for J0, K0 too. Once state table is written, you find out what are the flip-flop inputs. So first for J2 we'll find, I'm just mapping J2, K2, J1, K1, J0, K0 to K-map. So J2 you can see it's 1000XXXX. So inputs for your K-map would be Q2, Q1, Q0, which are your present state. After mapping, I'll group these two, I'll get Q1 bar, Q0 bar. Grouping K2, I'll get Q1 bar, Q0 bar. So J2, K2 is Q1 bar and Q0 bar. Then J1, K1. So J1, K1, again I'm from state table, I'm mapping here. So I can group these 4. So what I'll get? Q0 bar. Similarly, K1 is Q0 bar. So J1, K1 are Q0 bar. What is J0, K0? You can see you have 8 minterms, either 1 or X. So you can group all the 8 minterms of your K-map. So when you group all the 8 minterms of your K-map, you get J0, K0 as 1. And this is your schematic. So every flip-flop is connected to common clock because it's synchronous design. Every state changes with respect to common clock. So J0, K0, you can see here, it's given to logic 1. And J1, K1 is Q0 bar. So just this is your Q0 bar connected here. And J2, K2 is Q1 bar, Q0 bar. So this is Q0 bar and this is going to